In this lesson, we will explore elaborations on the selection structure. After studying this lesson, you should gain a strong understanding of multiple decisions, a first look at nested decision structures, nested decisions, deeper dive with VB development, nested decisions continued, designing the GUI, alternative decision structures, select case structure with investigation of efficiency, code clarity, and range selection, using radio button controls, mutually exclusive GUI choices, message boxes for enhanced user communications and interactions, and using the KeyPress event with additional commentary on efficiency with AndAlso OrElse. Let's take a first look at making multiple decisions in a program, and we'll do a couple of these. This one we'll try and keep fairly simple, and we're going to chain these decisions in such a way that one decision leads to another decision that has to be made. When we have that circumstance, that's known as a nested decision. It's one decision wrapped inside another decision process. Okay, so here's our scenario. We're going to simulate a basketball practice game as follows. We're going to generate a random number that's either going to be 0 or 1. And so it's 0 is even, 1 is odd. If the number is 0, we're going to say, hey, the ball went through the hoop. Otherwise, it missed. And if the ball went through the hoop, then we're going to make another random generated number that says odd or even. And if it's even, if it's 0, then the shot was an outside shot. Hey, it's a 3-pointer. Otherwise, it's an inside shot worth 2 points. Okay, so we're going to provide the appropriate outputs in all cases. Which is just going to be a string message. You missed the shot, or that was a 2-point shot, or that was a 3-point shot. Okay, so let's start by setting up our declarations. And so it's going to be 0 or 1 is going to be our random generated number, odd or even, so that can be just an integer type. And then let's see here. I'll put a comment in as we go. So generate a random number between 0 and 1, and Flogorithm, the way we do that is odd even equals random 2. And remember that the upper bounds is exclusive, and if we don't specify the lower bound, which Flogorithm doesn't allow us to do, but in VB it's optional, it's going to default to 0. So 0 to 2 exclusive. 0 is inclusive, 2 is exclusive. You'll remember my lecture on that. It's kind of confusing. Yeah, too bad. Sorry, get used to it. It's the way VB does it. This will give us either a 0 or a 1 result. Okay, so now we don't have to depend on the user making input all the time. We're going to have the machine, so it's sort of like a machine simulation. The machine is going to generate for us whether the basket went in or didn't go in, and then same logic, we'll repeat it again for was it a 2-point shot or a 3-point shot. Okay. So fair enough, and let's see here. This is where we come up with our first decision, and let's say if odd even is even, if it equals 0, then well, let's see. If it isn't, and we don't have to code for 1 because we know there's only 2 possibilities. So if it's not 0, ergo it must be 1. So the shot missed, and let's output a message like swish, no basket. Okay, and then what if it's true? Well, let's see what we need to do on that side of the house. Okay, so if it was 0, the shot was good. Now we need to determine, was it a 2-point shot or 3-point shot? Okay, and so we can just model on our original decision kind of the same way. And If it was even, so we generate another random number. If this one happened to be 0, then hey, if it was 0, this is a 3-point shot, and we'll output a message like, shot from the outside. It's good, 3 points. The crowd goes wild. Okay. Otherwise, it's false. If 1, this is a 2-point shot. Input, inside shot goes in for 2. And we're basically done. That's it. So let's test our code and see how that's operating. All right. So didn't ask us for any input, and that's because everything was generated. So if we trace what must have happened, it generated a 0 for the first one, and so it didn't even have to look for the second one because we don't have to figure out whether you missed a 3-point shot or missed a 2-point shot. A missed shot is a missed shot. It's just swish, no basket. Okay, run it again. This time it's good, and it was a 3-point shot. And run it again, no basket. And again, no basket, no basket, no basket. Oh, there it is. There's a 2-point shot that was good. And so the way we've set this up on a 50-50, about half the time on average you're going to make a basket, randomly distributed, so we don't know what the order will be, and half the time it won't make a basket. And then of the baskets it makes, half the time there'll be 2-point shots and half the time there'll be 3-point shots. Let's see if this seems to hold true. Inside shot, good for 2, no basket. Outside, good for 3, no basket. Yeah, so this seems to be holding pretty closely to our expectation. The code seems to be running properly, and there we have it. And so this decision only has to be made if this decision turned out to be true. Otherwise, this decision never gets executed if this is false. And this decision resides inside on the right-hand leg of this decision. And so you can see visually the structure. You have one decision inside another decision, and those are called nested decisions. We could have more nested decisions. We could have, in a more complex algorithm, a decision nested over here. We could have a decision nested inside a decision, nested inside another decision, ad infinitum, as many decisions as you need for the layers of logic that you need to implement. So we can actually implement some fairly complex decision structures with a lot of things to be considered and a lot of different contingencies. Just need to be patient, do the proper analysis, and code it up appropriately. There you have it. Let's explore developing an algorithm for a set of decisions where one decision leads into another decision depending on the path that's followed. So these are called nested decisions. And so here's our scenario on an empty algorithm. Obtain the number of cookie baskets the customer wants to order. So this is for Cookie Palace, which is a made-to-order cookie service, and they make cookie baskets. And baskets are $35.99 each. And calculate the subtotal, which is going to be the number of baskets times the unit price. And then, if the customer is ordering 3 or more baskets, set the discount rate to 20%. Otherwise, ask the customer if they are a club member, and if they are, the customer is going to get a discount of 15%, and if not, we're going to give them just a new customer courtesy discount of 5%. So we're never really going to charge $35.99. We're always going to be at least 5% under that, but 15% if they're a club member, regular customer, and 20% if they're buying in bulk, 3 or more. Okay, so once we've got the discount rate calculated, calculate the discount amount, and that's going to be calculated as the subtotal time the discount rate that pertains in this case, and then calculate the total as a subtotal minus the discount amount, and finally display the total. All right, so you can go through by this point and do an IPO analysis, and you should be able to formulate the appropriate variables and the data types that you will need for those. And so I'm going to go ahead and assume that you have either mentally done that on your own, or we'll stop the video and step through that. And let me paste in our declaration. So integer for the number of baskets, reals for the discount rate, the discount amount, the subtotal, the total, and a string in this case. Could be a Boolean, but I've elected to make it a string for whether the club member yes or no or true or false. I'm going to use a Y for yes and an N for no. So I'm using a char or a string in this case. Okay, so the next thing we need to do is, according to our analysis, we need to prompt and get an input for how many baskets would you like, and input the number of baskets. And then once we've got that, we can start to do some processing. At this point, we can calculate the subtotal. This is the undiscounted subtotal. All right. With that in mind, we then need to make a decision. And the decision we need to make is the number of baskets, 3 or more. Okay, so if num baskets is greater than or equal to, remember your boundaries, okay, so 3 or more, greater than or equal to 3. So if it's greater than or equal to 3, then that's pretty easy. Then our discount rate is going to be 20%. But what if it's not? Well, then we have to get some more input from the user. And here is where we have to decide, are you a club member? And then get the result. Okay, yes or Y for yes and N for no. Now, we could have, if you think about it, let's take that and cut it. We could have asked that question up here. Why is that not the best thing we could do? Do you see it? All right, so if we're asking the club member here, but if they're ordering more than 3 baskets, it doesn't matter whether they're a club member or not. So why solicit additional input, waste the customer's time, waste our time, make things more confused about, but I thought I get a 20% discount. Why do you need to know if I'm a club member? We just don't want to go there, okay? It's not necessary, so it would be much better, even though it will work if we were coded up there, get the input be way before the decision. Let's make the input more adjacent to the decision. So let's put it down here. Okay, are you a club member? And here's where we can really benefit from that. And this is our nested decision. And it's going to say, okay, if club member equals Y, and I'm going to do it this way. I'm going to say or club member. What else are they likely to hit that's going to be confusing? Lowercase y, right? And we could force this to an uppercase, or all lowercase. That would be another approach. I'm just going to do it this way. It's a little bit easier given the Flowgorithm tool. But lots of different approaches. So either an uppercase y or lowercase y. I don't have to code the no because anything that isn't uppercase y or lowercase y, I'm assuming, so if they put in something silly like X or K or, they type their grandmother's name, doesn't matter. I'm just going to say, you know what, you didn't respond with a Y, I'm assuming you're not a club member, you don't get the discount. Okay. And so here, again, we want our discount rate. So I'm going to copy this and paste it here and paste it here. Only in this case, if they are a club member, it's 15%. And if they are not a club member, I'll still give them a courtesy 5% discount. And then coming out of the decision set, we need to do a couple calculations. So the first calculation that we need to do, and notice that rather than making this calculation 3 different times, I calculate it here, I calculate it here, and I calculate it here, I wait until we're all running those and merging them together because this is exactly the same formula. All that's changing is the discount rate. The formula itself stays the same. So I can be much more effective putting the code for that calculation in one place and one place only. Put it right down here after we merge. What would be the disadvantage? Could it still be correct if I copied it in all three places? Yes, but if you ever have to make a change, you got three different copies of the code. What are the chances? Are you going to leave one of them out, or it's going to be somehow different? It's just more chance for error. So the more we can reuse and consolidate code, the better. So I'm going to put that on the common path out, and then I need to do another little bit of calculation here, and that is set the total equals the subtotal minus the discount amount. Now, I could have made this into one big ugly calculation. It's clearer to break things into steps, I think, and so often that is the choice we'll make. We kind of balance between, is the code um, getting longer, or is it shorter but more complex? And generally, the better rule is to lean in favor of clarity over compact but complex code. Okay, complex code just makes it harder for other people to, or yourself, to later maintain or edit or revise the code. If you take it in stepwise pieces, it's a lot easier to maintain. And then last thing we need to do is the output of the total. The total for this order is $ and total. And let's run it and see if we are working correctly. So we want to test above our boundaries, on our boundaries, below our boundaries, and then for the case where we are a club member and are not a club member. Okay, so really need a fairly robust test set for this. So first, let's test for above our boundaries. So if I order 4 baskets and $115.17, I didn't bother to format the values here in our flowgridim. We'll see how to do that when we bust into VB. But just as a matter of course, so if we learn to sanity check our work, basically $36 a piece times 4, 36, 72, 144 with a 20% or $28 value. Yeah, that looks like it's about right at 115. So without busting down to do the math, I can still sanity check and go, yeah, this seems to be right in with expectations. So that's good. Let's run it again on our boundary. What if it's exactly 3? Which way should that go? And yep, looks good again. Got our 20% discount. And then let's go below that. What if there are only 2 baskets? Okay, in that case, I need to be prompted, am I a club member? Let's say yes, I should still get a 15% discount on 2 baskets. And yep, that seems about right. And then let's do 2 baskets again. But this time I'm going to say, no, I am not a club member. And I don't get as big a discount. So again, checking at 36.72 less 5% ought to be about $3 and change. And yeah, that looks about right. So good. So we've tested our outer decision and our inner or nested decision. We've tested above the boundary, on the boundary, below the boundary, and both possibilities here. And so we've tested it pretty thoroughly. So I would say our logic is correct and complete. And now we're ready to move on to translating this to a GUI and putting it to work in a Windows Forms application. Let's continue with our Cookie Palace example. And I've gone ahead with the toe chart development and the wireframe design offline. You've seen how to do that now, and come up with this interface design. And accelerator keys are also added in. So I've got the baskets ordered, whether or not the purchaser is a Cookie Club member, and then the total owed. And again, I differ slightly in the textbook's author's approach. I tend to use a text box and disable it. The text box author goes through a little more work to make this a label that looks like a text box. And being a label, of course, it is not something you can type in. Okay, so I get the same result with slightly different approach. That's fine. Let's just see this with no code running. I think the only thing I've coded up actually is the exit button. Okay, so we can put in the number of baskets we wanted to purchase. We can toggle on and off whether we want the purchaser to be a Cookie Club member, and our calculate button does nothing, and I have coded up the exit button, and there we have it. Okay, so to get a running start on our logic, we'll just have to convert the user interface elements. I'm going to go over to our working Flowgorithm code. Nice to have that all up and going. And let's go to our tools and the source code viewer, and let's change that to look at, let's see, where did I put the template for that? I think it's in CIS-119 on my computer under Flowgorithm in the source code templates. And here's the latest version. And so I'm going to go ahead and copy that to the clipboard. Good, I'm done with that. And now let's go ahead and see if we can migrate that old console-based code into this nice GUI interface that we've built. So I'm going to make a little bit of room and paste that in. And again, it comes bringing in some code I don't need. So this is the event that I'm coding. I need to get rid of the imports and the module and sub main. And then at the bottom, get rid of the module and the main. And let's see, we won't need the private sub for console input and output. So I can get rid of that sub and that function as well. And also will not need the read key. And here is our code, only I need to fix the inputs and outputs to work with the form that we've designed here. Okay, so all of our variables should be fine. We just need to add in the try parses to convert them from the inputs into the variables, and then put the variables back out to strings for the text box when we're ready. So rather than output how many baskets would you like, let's see, we don't really need to do that, do we? Because we have a text box with a label doing that job, so we'll delete that. What we will need to do is convert the number of baskets into that input value, and we're going to do that with a try parse. Oh, let's see, what did we name our baskets ordered? Oh, I've got it left as text box 1. How about txt num baskets? That's better. txt num baskets and store the result if that can be converted into num baskets. Oh, it's the text property we want. Thank you, IntelliSense. Okay, and then subtotal is fine, times num baskets is fine. This logic is fine if num baskets greater than 3, discount rate. And now we need to determine if the user is a club member. So we can do this rather than prompting the user, we're going to read the checkbox. Okay, so what we're really going to say here is if, and did I also forget to name that checkbox? Oh, CB club member dot checked. And we can do that a couple ways. We can say if it is equal to true, or we could also just say if club member dot checked, because that expression is going to be evaluate to either true or false. It's checked or it's not checked. Okay, so whichever way works better for you. If you like it more explicitly, then do it that way. That's fine. So if it is true, then what? Then we're going to do something. And so if it's true, the discount rate is going to be 0.15, else the discount rate is going to be 0.05. And so we can dispense with this part of the code that did all that for us. Great, so now it reads, if the number of baskets is greater than 3, you get a 20% discount. Else, if you are a club member, then you get a 15%. Otherwise, you get 15%. And now we go on with our calculation. And that's going to be the same calculation no matter how we got there. Subtotal times discount rate is the discount amount. The total is the subtotal minus the discount amount. And now we need to replace this output with putting that text into our text box. And let's see, did we name our text box correctly, or we still have it at the default name, text total? Okay, so we named it properly. Good. So what we're going to say is text total dot text is going to be set to, and what was the variable we're using that? Total, and we're going to convert that to a string, and that replaces that line of code, and we should now have a working program. Let's give it a shot. F5 to run, and if I order, so let's test high for calculate, and this should be true whether or not they are a Cookie Club member, because we don't really even have to ask that if they're more than 3. Let's test it 3. 86,376, yep. 86,376, but what if it's 2 and they are a Cookie Club member? 6183, but if they are not a Cookie Club member, 6838. Okay, so this all seems to be working properly. And then the other thing that we might want to do is let's take care of the formatting on that. Let's turn that into a nice currency and bring it to just 2 decimal places. That would be a good thing to do there. All right, so we can use a format template when we do our 2-string conversion. And if we want it to 2 decimal places currency, C2 is the template that will do that. And what's really nice about this, notice that I'm not having to specify whether I'm working in dollars or won or baht or pounds or lira or rubles. That is going to be dependent upon what my operating system is set to, so it will automatically inherit that from the environment that Windows is running in, or in the case of the .NET framework ported to Linux and other platforms, the whatever the operating system, the code page is that it's running, which is going to set things up like the keyboard set, character set, and the symbols for currency and whatnot. So let's go ahead and see what happens when we set the formatting to C2 here, and if that works properly. And let's have one basket for a Cookie Club member, calculate, and now I have $30.59 with the $sign formatted as currency to 2 decimal places. Gotta love that. All right. Hi, let's take a moment and explore some of the efficiencies and inefficiencies that we can achieve with decision structures, and then we'll look at an alternative decision structure known as the select case structure. So let's take a look at this form I have set up. There's a simple input box and an output box, both text boxes, and we're just going to build some logic that says, hey, if the user enters this, then the output is going to be that. The go button is going to fire that off and cause that code to be evaluated. Okay. So to start off with, I've said simply, hey, if the input box text is 91405, that's the zip code for Van Nuys, California, then output the text Van Nuys. Let's do something similar for a couple other zip codes. Okay, so we can take this whole if structure, and one of the things we could do is, because it's only going to be one of these, we could paste it in and say, yeah, but if it's 93004, then it's going to be Ventura, and then we could say, yeah, but if it's going to be 93109, then it's going to be Santa Barbara, and we could even do something really tricky here, and we could say, let's start out by saying, first let's clear the output text box. And we'll set up all other cases that would be untouched. If it's not one of these, then nothing's going to happen to change what's in the output, and we'll say the text is unknown zip code, unknown zip. Okay, and that seems all straightforward. Let's run it, see what we get. F5. And let's try 91405. And as expected, we get Van Nuys. And how about 93004? Yep, Ventura. 93109. And unknown zip. Oops, because I typed it wrong. So that we've tested that. That case works. 93109. And we get Santa Barbara. And let's see if I remember from my childhood watching too many game shows. The sponsor was the Spiegel catalog, Chicago, Illinois, 60609, I believe. And go, and yes, that's an unknown zip. Okay, so this seems straightforward, and you might imagine that you've done this in the most efficient way possible. And let me tell you and show you why that is not the case. And we can achieve better, more efficient code. And of course, better, more efficient code is a virtue in itself, but it also means that, if you're the one who can write better and more efficient code, you're going to get promoted up and be ultimately the team lead or the lead programmer, and eventually the lead analyst and systems architect, and a manager and your career progresses, because you can do it at a, get function at a higher level, achieve better product, and help to foster that in your colleagues. So those would be good things. Now, let's just think about what actually happens to understand why this is not very efficient code. Okay, so walking down these tests, we're going to, let's assume that the zip code is 91405. So we come in here, it's 91405, that's a match, we update the text, and we're done. Now, we're going to waste CPU cycles because we've already met our match. If we've already met our match and it can only be one zip code, why on earth would we bother to test to see if it is 93? We already know it's not 93004. Why are you testing for that? But we're going to test it anyway. It's going to fail, and there's no change made because it still says Van Nuys. We come at 93109. It says, well, yeah, but we already know it's 91405. Why are you even bothering to test? But it's not, so we don't change it to Santa Barbara. So we ran a whole bunch more CPU cycles doing these tests uselessly, needlessly. There's no point in doing those. Okay, so perhaps a better way is if we can at least improve. We can't always know in advance which one it's going to be, but how about we stop testing as soon as we do find a match? And we could, if we knew that there was more likelihood of one of these being the more popular zip code for our applications. So, let's say most of our business is done in Van Nuys, and 20% of our business is done in Ventura, and 10% is in Santa Barbara, then ranking them this way, let's test first for the one that's most likely. Okay, and what let's do is, instead of ending the if, we could say else if. And you could do this with an else if, or an else and a following if. And another else if. And then let's run. Does this still do what we intended? Well, let's go ahead and try it. Okay, if this 91405, go, and Van Nuys works, and let's try 93004, and that works, and 93109, that works. And does it still work for the unknown case? Spiegel catalog, Chicago, Illinois, unknown zip. Okay, so that's all working. Now, is it really true that the code stops when it finds the first match? Well, to see if that's true, we can set a breakpoint here, right? So, or let's say down here. If it never runs this breakpoint, if we enter 91405, if it never stops here, that means that code never was evaluated. So we can find out if this code gets evaluated by setting a breakpoint there. And let's come in here and say 91405 and go, and it didn't hit the breakpoint. We're still running 91405 and go. Okay, so let's see, what other code could we try? 93004. Does the code get evaluated? 93004, go. So we did get to evaluate Ventura because this failed, but we didn't evaluate the 93109. It's only if we put in the 93109, and now we hit the breakpoint. So we've just proven that this code, and by implication, the code above it, the code above it doesn't get run if we don't need it. So if we found a match sooner, we are not spending CPU cycles, so our code is much more efficient. Now, a lot of times when we're doing user interface stuff, that is glacially slow compared to how fast the computer is. And so, do we really need efficiency where we're waiting on the user? Do we need to save time? And well, possibly not. However, get in the good habit of thinking about efficiency, and wherever you build your code, and build it efficiently. If we were running something that was making decisions based on machine input or big data files that are being processed and are all ready to go. So there's no waiting on a user. They're running at machine speed. Saving those extra machine cycles can make a huge difference in the overall throughput of our processing. And when you take these little efficiencies in a system and multiply them by the many, many tens of thousands or millions of lines of code that might comprise the overall information system, the benefits can be huge. And so there really is a tangible benefit to paying attention to efficiencies and coding best practices. So now let's take a look at this code that is making these three decisions, really four. There's an implied fourth, and that is if it isn't any of the above, then it's going to say unknown zip. And think, what if we added, another 100 zip codes in the country? Holy smokes, this is going to get really kind of ugly and awkward to, maintain this code and this structure and all these nested if statements. And wouldn't it be nicer and cleaner if there was an easier way to do that? Well, there is an alternative selection structure that we can use here, and that is the select case, and we'll explore that next. All right, so in preparation for our conversion to the select case, let's add some variables here so that we can do a little bit of variable-based processing. We could use it all using the object properties, but that's not really the best practice, and it tends to be a little bit cumbersome. So let's come down and, we could do this even before we get started here. Do all our declarations right up front. That's a good practice. And let's just call this kind of generically user input as string. Okay, and so then let's come in here, and when this go button is pushed, let's set user input equals txt input box text. Okay, and that should already be a string format, so there's no conversion necessary. Okay, and now let's get rid of our entire if structure here, and we're going to replace this with a select case. And here we're going to select case on user input. And this is a multiple choice type of if structure, if you want to think of it that way. Okay, so we're looking at the case, and then having looked at the case of the user input, we can specify all the possible cases that this could be. So it could be 91405, and we could also have, let's see, in case 91405, then we're going to go ahead and set our text output dot text equals Van Nuys, and then we're going to specify our next case. And let me look at my notes. 93004 for Ventura. And I'm going to save myself a little typing by copying this line, and I'll just edit it. So we'll change that to Ventura. And our next case is going to be 93109. And that's going to be Santa Barbara. And let's make that a string. Oops. There we go. And I got to spell it correctly. There we go. And we could even clean up having to do all of this mess, because ready built for us in the select case structure is something called case else. So in all other cases, all right, let's see if this runs. F5 and 91405 and go. It's Van Nuys. Okay, what about 93004? Yep, Ventura. And 93109, Santa Barbara. And let's see, sponsored by Mr. Monty Hall's wardrobe, provided courtesy of the Spiegel catalog, Chicago, Illinois, 60609, I think. I'm not misremembering that. And that one's unknown. Great. Now, let's take a look at how this is to read and maintain. Oh my goodness, look at how clear and concise and straightforward this is. So if we have to go add additional zip codes in here, literally we could just come in here and copy and start pasting additional cases, bam, 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 and then modify those and add all the additional cases. And our code still is very clear, very readable. There's not a lot of indenting or brackets or parentheses or things that we have to navigate. And it's very easy to delete and maintain it the same way if we need to do reductions on choices, as we might in businesses. Business needs come and go. Okay, so this is nice and tight. Let's see if it is also efficient. So is it actually testing all of these, or is it stopping? Okay, so let's put our break now down on unknown zip. So if we never reach this breakpoint during a run, that means that it is stopping prior to that, and so it's not wasting CPU cycles doing evaluations that do not need to be done. Let's find out experimentally if this is an effective or efficient structure or not for that purpose. Let's hit F5. And our code builds and runs, and let's put in 91405, and it runs without a break. How about 93004? Yep, and it runs without hitting the brake. And 93109, and it runs without hitting the brake. And then 60609. And that's where we hit the brake. Okay, so we're only executing as much of the code as is necessary to find the true case, and the rest of it we're abandoning, and it's just going on without executing or evaluating all that code. So that means that if we have, let's say even chance that any one of these four is true, if we were to do all of it, that's worst case. If we were using an inefficient structure, so part of the time we're going to be, 1/4 of the time we're going to be 25%. 1/4 of the time we're going to be 50%, 1/4 of the time 75%, and 1/4 of the time 100% of the worst case scenario. So the average is we're going to be 50% of the worst case scenario. Or looking at it another way, that means if we're only if we're 50% on average of the worst case scenario, then we are 2 times as good as the worst case scenario, or twice as efficient. Or put it another way, the reciprocal of 1/2, 1/2, we're half as slow, or we're twice as good. Take the reciprocal of it, and that's the way to look at that. So this is a 50% efficiency, or a twofold improvement over what inefficient code would be. And again, you can see that maybe not in processing user input, But in doing business logic where you're processing large volumes of data, it doesn't take too many of those kinds of efficiencies to really improve your code, or looking at it in the negative, it doesn't take too many inefficiencies to really kind of trash your code and make it very, very poor performing. And so these are the kinds of things that are worth looking at and considering as we think about our coding. So also you look at how easily the case select case structure is maintained. You can see that, when would I use this? Well, a good rule of thumb is if you are going to have to otherwise nest more than about 2 or maybe 3 if cases without using the select case, if I'm going to have to nest more than 3, I definitely want to see, can I use a select case to do this? All right. One more trick up our sleeve, and that is select case actually handles ranges really, really nicely. Okay, and so let's modify our problem statement just a little bit so that we can see that. So let's change this so instead of dealing with zip codes, we'll deal with numbers and ranges. So we'll do that next. Let's start by changing our prompts just a little bit. So instead of if this, then that, let's change this over to address a quantity ordered. And the quantity ordered is going to determine, let's say, our price per item. So let's change this label so that it says if quantity is, and let's make that a string literal. Stop the debugger. There we go. That's what it's not liking my change. There we go. The quantity is this. Let's back that label off. And we'll change this to then price per item is. And we'll back this off a little bit. Let's make a little more screen real estate here, shall we? There we go. All right, so what we're going to do here is we're going to offer a reduced price depending on the more someone buys. So we're going to use a range. So 1 to 5 items, let's make $25, and 6 to 10 items, $23. If they buy more than 10, it's $20. If they buy fewer than 1, well, that would be 0. So we'll put that in the logic as well. So let's go back to our logic here. And so we're going to get our user input. Now it's going to be the price per item. And we need to change this. Let's make this into a, let's see, are we going to have whole dollars only? We're going to have floats. Let's make it whole dollars only integer. So we'll make it as integer. And then if we're going to convert this to an integer, we need to do an integer try parse on it. And we're not going to evaluate the result code. We're just going to make that transformation. And if it doesn't work, it'll just fail silently, but it won't cause our program to end because we've trapped for it. All right, and then we're going to change all of our cases. And so now we want to look at this as a range. So let's say the case is um, let's say 1 to 5. And then we're going to set our item price at 25. So in that case, we'll make, and we could be putting this into a variable. We're just going to pop it right out into the text box for now, for simplicity's sakes. So text output dot text equals 25, and if I make that text, I don't even have to convert it, so I've just provided it as text. Probably ordinarily would be in a variable, and we'd have additional numerical calculations on it or going on, and we would convert it then before we've stored it in the text box. But since I'm just storing it directly, don't even have to change it. Okay, so 1 to 5, and then let's copy this case for the other cases we might want. So 1 to 5, and then 6 to 10. And then let's see, this case is just going to be anything greater than 10. And so we can use a slightly different expression here. Case is, that's pretty cool. Haven't seen that before. Case is greater than 10. And let's see, for 6 to 10, the price is going to be 23. And greater than 10, we want it to be $20 each. And our case else, well, let's make that 0, because the only thing that's left is going to be, we've got 1 to 5, 6 to 10, and greater than 10. So the only other thing that they could enter would be a range that would be less than 1. So we could have a case there, for cases less than 1. But let's just do it this way, because anything left over is going to be what's less than 1. That's the only possibility that's left. And so let's just make it 0. All right. So isn't this efficient and cool? Look how few statements we needed when we express it as ranges. All right, let's get rid of that breakpoint. Don't need that now. And let's test our code and see if that runs. Okay, so what if I order 0? The price is 0. What if I order something crazy like negative 300? Then still 0. Can't order negative 300. What if I order 1? Well, price each is 25. What if I order 5? Price each still 25. Anywhere in between? Still 25. What if I order that 6th item? Price each is now 23. Okay, and 7, still 23, and 8, 23, and 9, still 23 because I'm still in the range, and 10, still 23 because it has to be greater than 10 before I get the next level discount. 11 should break it, and now anything more than that should be $20 a piece. What if I order 1,000 of them? Well, that's more than 10, should still be $20 a piece. And so that's working. And look how elegant and clean and how easy to maintain. If we wanted to cut this a little bit finer, it's very easy to add another boundary in the case, another range. So let's say we made case 3 to 5, and we made this case 1 to 2. So 1 to 2 are 25, and txt output and we made this $24 each. Why doesn't, oh, because I forgot the equal sign. Gotta love that IntelliSense, keeps you out of trouble sometimes. Okay, so we very easily modified this to address a changing business requirement. And all of our logic so elegantly laid out, so easy to read and understand, as opposed to if we had to do the same thing with if structures, we could still do it. It would work perfectly well. But how nice. And again, this remains efficient, and we can prove that. So let me put the breakpoint here, for example, case 3 to 5. If I solve the problem right up front, are any other evaluations needed? If we hit a breakpoint, if I put in 1 or 2, then we know that something's going on. I'm not being efficient. But if we just go ahead and stop right there, or we can actually we continue, we don't hit the breakpoint by putting in a 1 or a 2, then our code remains highly efficient. So let's test that. And let's put in a 1 and no breakpoint, and a 2, no breakpoint. Now if we hit the 3, we get the breakpoint. And again, what that tells us is that the code that is not needed to evaluate, if we get lucky and we have found our qualifying case, the additional cases do not get evaluated, so we don't waste CPU cycles and machine and processing time and resources that we don't need to if we've already found our answer. So this remains a very efficient structure, and that's what we're shooting for. So there we go. So to sum up, we can make our if structures, our decision structures, more efficient by nesting them rather than doing serial cases that are serial if statements that always get evaluated even once we've already found the answer. We can inherit that efficiency by using a case structure. Anytime we use 2 or 3 or more nested if structures, we should probably consider whether we can use the case structure to make our code a little cleaner and more readable. And then finally, we can also use the case structure to very handily deal with ranges using the to operator and the is operator. And of course, we have the fall out of bed option, case else. So when nothing else worked, it didn't meet any of our other qualifying cases, this becomes our default case. So neat. Have fun with the case statement. Now let's explore radio buttons. But why the heck are these Windows form controls called radio buttons anyway? Why not elevator buttons? Well, unlike elevator buttons, where several can be pressed and pending at once, a radio button harkens back to the classic days of automobile radio, where we had a console with push buttons for our radio, and we could set a radio frequency, a particular station, by first tuning to that station with the knobs, and then pull one of the knobs all the way out and then push it all the way in. And that adjusted a pivot plate and a gear and locked down a preset offset in the armature for the tuning condenser for the radio. And it was all very, very clever, a totally mechanical way for you to preset and save your favorite radio stations. The key point is that in one of these radios, the old car radios, only one button could be pushed in at a time. Pushing any one button in would push the one button that was already pushed in out and pop it out, and so it would replace it. So the idea is that when used in a natural sort of way, or as the designers intended, a radio button in a group, only one radio button can be pushed in at a time or selected, as opposed to a checkbox, where a checkbox might be a multi-select option. So, let's say you're choosing ice cream. Do you want sprinkles? Do you want hot fudge? Do you want whipped cream? Do you want cherry on top? Those would be like a checkbox choice. You could have all of them. Just check all of those that you want. If we are getting a single scoop and we don't, the ice cream store doesn't allow us to split scoops, we have to choose one flavor. Do you want chocolate, strawberry, or vanilla? And choosing one means you're not getting the other two. That would be more like a radio button choice. Now let's play with some radio button controls and see how these work. So I have an empty Windows form project up and running now, and we'll come into the toolbox and find radio buttons, and we'll drop one on here. And I'll kind of drag it out, and Control C to copy it, Control V to drop another, and I'll align that, and Control V to align a third. Nice. And let's just see how these behave to start with. So I'm going to hit F5 and just run this program as it is. Doesn't really do much. Now we notice that in the main form, we didn't tell it to do anything, but the radio button that had the lowest order tab stop, the tab order with the lowest value, has been checked automatically for us. Okay, we can then select any of the others, and these also, since they're unstructured and just lying loose on the main form, they're considered to be in the same group. And by default, radio buttons are mutually exclusive. So clicking any one of them automatically unclicks the other button that is clicked. Okay, so one way we could change the default on the radio button to see which one is to be clicked first is we could change the tab order. If that's objectionable, if you want to lay it out so that a radio button with a higher numbered tab order is for some reason going to be the default, probably the easiest thing to do would be to go into the form load and set it so that when the form loads, that the radio button that you want to be the default is selected or checked. Okay, so let's go ahead and do that now. Okay, so let's, while we're at it, give these more meaningful names and also captions. So I'm going to call this RB for radio button small, and let's have this display the choice small, and we'll make this one RB medium. Oh, we'll make the text medium. And the name RB medium. And we'll make this one large. And the text large. All right, so we've got those named and labeled the way we'd like. And now let's just double click on the form to get the form load event. And let's say we want to make the default. So these are maybe ordering sodas. So the most common soda we sell is the medium. Most people don't want the small or the large. So when the form loads, let's take RB medium dot checked and set that equal to true. And let's give that a run, F5. And now, by default, it's set up medium as the chosen button, and we can, of course, override that. But since most of the time, this is just good user interface design, we make the most common button that we want to choose the default. Even if it isn't logically in the tab order, we could sort these so that the natural order, the medium was first, and maybe that would be okay to do. But it's also kind of counterintuitive that you would go medium, small, large, or medium, large, small. So this is maybe a little bit more natural interface, and yet the most likely choice, the most common choice, is set as our default. So pretty defensible user design there. Okay, let's end that. Go back to our form design. Now, imagine for a moment that in addition to the size of our beverage, we wanted to select which beverage is it that we're ordering. Okay, so let's drop some more text buttons on here. Excuse me. text buttons, radio buttons on here. So here's another radio button, and let's copy that and drop another one down and another one down, and we'll make one, Coke and one Sprite and one maybe fruit punch. Let's go ahead and run this before we do that though and see, is this working the way we intend? Well, no, because these are being seen as part of the same group. So we really want to have an exclusive choice in small, medium, or large, and for that small, medium, or large beverage, an exclusive choice as to what beverage it is, what flavor. But we don't want a medium nothing, and we don't want a Coca-Cola with no size. So we need to do something to get them into separate groups. And by default, anything that's just dropped willy-nilly on the main form is going to be part of the default group. So there is another control we can make use of here, and that is the group box. And so if we come over and find the group box and drag that out here, and then if we take all of the buttons we want inside that and drag them into the group box, so see, they move with the panel. They're now on the group box. And F5, and let's see how this works now. Now, interestingly, notice that within the group box, none of these buttons is checked, but they are working independently of those that are not in the same group. So if it's in a group box, there is no default. So we could go play our trick on the form load to set the default, or the easier way, and ordinarily we'll put all of our radio buttons into a group box. It's kind of best practice. If we wanted to, let's say, make the first choice here the most common, we would come in, select it, and in the design time, if we set checked, since none of them will be checked, that one will be checked by default. Why couldn't we play that same game here when they're not in a group box? Because the tab order is going to automatically set the lowest tab ordered radio button is going to be checked by default. So kind of funky, but once you understand the behavior, easy enough to understand. All right, so what we probably ought to do here in this group box, let's see if we can give the group box something meaningful. Either we ought to get rid of the text altogether, or give it a meaningful name like flavor. Okay, and then for radio button 1, how about we call this Coke. And let's call radio button 2 RB Sprite. And you could use Pepsi flavors if you like. I don't mean to be shilling for the Coca-Cola company. They don't pay me any residuals, more's the pity. And fruit punch. All right, and see this work one more time. So medium Coke is what we've set by default, probably the world's most common beverage choice, at least in most US fast foods restaurants. And there we go, and we can overwrite it and instead make that a small fruit punch. And that's it for the buttons. Here's a fun little program that's going to help us to demonstrate the message box show method. And so let's first explore what's going on in this form so far before we introduce the message boxes. So I've got a list box here, and I've got a push button. And what I have done is I've set the default on this push button so the enabled is false. So when we first run this, it's going to be disabled. The button's of no use at all until we take some other action. And the action we're taking here that is going to enable that is when one of the list box items that we've put into the collection to start with, it gets selected. And when one of those gets selected, then the delete button is going to be enabled. And let's take a look at how some of that code works. Okay, so here's the event that's going to enable the button that starts out being disabled, and that event is when the selected index is changed. So when right now there's nothing selected, so when something on that list box gets selected, then the delete button gets hot, it becomes live at that point. Okay, and so what are we going to do there? So once that is live, if you then click the button, the list box item is going to be removed. And so we're going to use the remove method. And what is the object we're specifying? Well, it's the selected item of the list box gets removed from the list. And then kind of redundant, but at that point, the selected item will be cleared. Well, it's gone. It'll be cleared anyway, but this will be handy to have in there in a minute. We'll see why. And then I'm going to set that button back to disabled again. So in other words, enabled equals false. Okay, so let's just watch how this works at present. Okay, so my button is disabled because I don't have anything in context. And having contextual clues in a user interface, such as graying out things for actions that cannot currently be done, is really a good thing. It helps the user to be more intuitive about when can I do something, when can I not do something. And by graying it out, rather than making it invisible or gone, I can see that there must be some way that something can be selected. So what do you guess? Well, maybe if I click on it, oh yeah, when I click on it, that gets hot, it goes live. Okay, so if I want to delete that item, I hit delete selected and Ray Norda is gone. And we can do the same thing with Bill Gates and Larry Ellison, and yay, Ada Lovelace and Grace Hopper rule. So true. Okay, so if you don't know who Ada Lovelace or Grace Hopper are, I challenge you to look up some of these great people in the history of computing. We'll leave that as an exercise for you. So our deletes are working. Our button is becoming enabled or disabled. But that's a hair trigger for deleting something that maybe we want to make sure we meant to do that before we just throw it into the chopper. So let's see what we can do about that. So maybe before we just come and pull the trigger on deleting that item, we want to ask the user, hey, did you really mean that? Do you really want to delete it? And yet we don't want to really mess up our nice clean interface. So we don't want to have a lot of messages on the form turning on or off, or things becoming visible or invisible. Those would be the other ways to do it, and they have their place. But how about if we pop up a separate panel for that? Now we could have a whole nother form that we build, but gosh, having to go to the trouble of designing and laying out and coding up a form for something that we're going to do a million times, simple messaging, there's got to be a better way. Well, there is. The message box object allows us to do that pretty nifty or pretty handily, and it's got some really nice default uh, icons like the exclamation mark for warning, or stop for something, a critical stop, or other icons to let us know that, hey, is this advice? Is this really critical? Is this a bad thing? And we can also put a caption on it. and control what sort of buttons the user has to choose. And in this case, we want to basically say OK or cancel. We could conceivably say OK, cancel, or add a help button. Give me more information about that, or code other functionality. But in this case, I think a straightforward OK or cancel is probably all we need. So let's go back into our delete routine and let's see. What we need is when we are about to do this deletion. Let's comment that out for right now. So before we do that deletion, we want to pop up our message box and then get our result from the message box. What did the user do with the message box? So how do we do that? To save time, I've got that in my clipboard. I'll paste it in. So forget the result for just a moment, and let's look at message box and the show method. And the show method, we are going to give the user a prompt. This is the main message of the message box. And we optionally, and any of these can be skipped or left blank, we can set a title for that message box. So here's something to give a little more information and context. So this message box says, warning, deletions cannot be undone. So that's going to be the title of that message box. It's going to give us the message, are you sure you want to delete this item? And then we can choose the buttons that show up. So this message box buttons OK cancel is going to give us the OK and cancel button. And then we can choose what icon is appropriate. So this is a pretty severe warning. So let's use the big yellow exclamation mark, message box icon dot exclamation. We'll do that. And then which button do you want to be the default? Well, the safe thing to do is to make cancel the default, the second button, so that if the user is a little bit trigger happy on the mouse, or as I often do, bumps the mouse up against the keyboard as they're moving things around and the button gets clicked, if it clicks, it's going to be cancel by default, which is non-destructive. At worst, the user has to go, oh, I really did mean to delete it, come back and do it again. Much less traumatic than accidentally deleting something. Okay. Now, let's go back and look at messagebox.show returning a result. So we have a result that can be returned here. And let's see, we probably ought to declare that, hadn't we? I think so. So let's come up here and declare the result as, and it's a dialog result object is its data type. Okay, so let's get the result from the message box, and that's really going to tell us what did the message, what button was clicked. Okay, and so the result is going to be dialog result if whatever the user clicked. If the user clicked OK, then we do the delete, and we don't need an else, because if they clicked cancel, then we're not going to do this delete. But what we're going to do, whether the item was deleted or not, is clear the selection and turn the delete button back off until the next time that the user selects something. So pretty cool. This one you got to play with a little bit, I think, to really see how the whole thing works now. But let's go ahead and try it. F5 to run. Okay, so again, we start off with the button disabled. Let's kill Larry Ellison. Delete selected, and now it's saying, wait, okay, warning, deletions cannot be undone. Are you sure you want to delete this? And it shows me with a big yellow exclamation mark and a triangle, hey, this is really calls for some caution. And if I hit cancel, the delete is not going to get processed. And it clears the selection and disables the button, and we're back to safe state. And if I went, oh yeah, I really wasn't trying to delete Larry Ellison. I really meant to delete Bill Gates. Delete, say, wait, are you sure? Can't be undone. Yeah, I'm sure. Okay, and now Bill Gates is gone, and it's returned the button to the disabled state until the next time that I select somebody that I want to delete or just end the program. Let's delve a little bit further into the concept of data validation by exploring the KeyPress event. And while we're at it, we'll work in a bonus lesson on efficiency, talking about the difference between the and or Boolean operators and the AndAlso and OrElse, let's call them short circuit operators. We'll find out why I'm referring to those in that way in just a moment. So here's a Windows Form project, and let's drop a text box on here. And I'm not going to bother to label or rename it because we're going to be working just with this one control pretty narrowly. All right, so if I double click it, by default, it's going to bring up the text changed event. What I'm really more interested in, however, is programming the KeyPress event. And so if I scroll up under, if I've got the KeyPress event demos, the project text box is currently selected, I'll see that there's another event I can code, which is called KeyPress. And when I do that, it left the text changed and went and created the event handler for it. Okay, I'm going to go ahead and get rid of the text change. Doesn't hurt anything necessarily to have an empty event handler sitting here, but it's kind of confusing, and it's probably poor practice to leave empty event handlers hanging around our code. So I'm just going to get rid of that. And now we can come in and code this up, and I'm going to save time by pasting from my clipboard where I put the code here. And let's walk through and see what this logic is going to do. And so it says if E, so this E, what is this E? E is the event argument that is being passed by the message queue. This is what happened that called our we're actually, when we create a handler, we're wiring up and hooking an event, and the E is the event name. And so in this case, we're catching the KeyPress event arguments. And those arguments that are going to be passed for the KeyPress event is going to give us, among other things, the code that was pressed on the keyboard. And so we can do some fun things with that, such as knowing the difference between the left and right shift key that were pressed, or was it the A or the B or the C key or the 1, 2, 3 key, or were there some meta keys that were pressed, the escape or control or alt keys or the shift keys? What's going on with that? We can figure that out by interrogating the KeyPress event arguments. Here, what we're going to be looking at is we're going to take the E object and we're going to look at the key character that was generated. And what we're saying here is if the character that was generated is greater than, notice that this is in quotes, so the string literal 0, if it's 0 or greater, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then going on, if we didn't close the end here with or, it's less than 9. So we're looking for key chars between 0 and 9. And also, let's put our line continuation operator in here. There we go. Line that up nicely. So this is the underscore, so it allows me to split the line without making it a new command. If the key char that was pressed is not the backspace key. So if it was 0 through 9 and not the backspace key, then I'm just going to say I'm done. It's handled. If it was something other than those, they're just basically dropping out. They're just going to be ignored. And so what I've done is I've created a form of data validation that says, hey, you know what? When the key press gets sent, I'm going to throw it away unless it was the digits 0 through 9 or it was the backspace key. And those, I'm not even doing anything special with them. I'm just going to pass them right on through. So they do whatever they do, which is to say they get stored in the text box, or the backspace key operates on the text box to destructively backspace over a character that was already typed. Yeah, so let's go ahead and run this. and see this operating then. Oh, I've got a duplicate up here from my setup before I started running the code here when I was getting set up for this video. So just ignore that. Let's hit F5 and run this and see what happens. Okay, so here is our text box, and I will press some number keys, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and now I'll hit the backspace key, and that backspace nicely. And now, I don't know if you'll be able to hear it on the video, I'm typing characters on my keyboard, and including the tab key. I might want to reconsider that one. I might want that one to work, but unless it is a number or the backspace key, it's going to be ignored. And this is a really clever way if we needed an all numeric input to validate this. And we could make our code a little bit more sophisticated and start looking at things like, if it had to be a certain pattern of alpha, 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 numeric, 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 alpha, numeric, was the format for some code for a part number or something that had to be entered. We could modify our code and add the logic in that would make sure that we follow that pattern, and we get really good data validation from that. So very cool. All right, now I've coded this up using and or, and you may be wondering, because the textbook author, quite rightly, has a tendency to show you or else and also and also. Okay, so having changed these to or else and also, let's see if we can determine if there's any difference in the way this code behaves. I press F5 to run it, and let's try and type something other than numbers. Nope. And what if I press numbers? Well, that works, and the backspace key still works. So what gives? Doesn't seem like there's any different. Well, actually, there is an important difference, and this code is actually more efficient. And let me explain why. In the normal OR, the computer comes along and it evaluates this side, and we know that the OR is going to be true if either one of these two sides happens to be true. So the computer comes along with the normal Boolean OR, and if this happened to be true, it would also still evaluate whether this was true, and either one of them being true, it would continue. But we would have wasted processing if this one if the left side had proven to be true, it would go ahead and still evaluate the right hand side. Why would it do that? It's a waste of time. You don't need to, okay? And so it's inefficient. What about and also? And also says that both the left side and the right side of the expression need to be true for it to be true. Well, the and Boolean operator will evaluate this one, and if it happens to be false, it will mindlessly go ahead and evaluate the right-hand side. Why? There's no point. We know if this is going to be an and operator, once the left side has proven to be false, it can't possibly generate a false. It's got to, or true, it's got to generate a false. So why bother to evaluate the second side after that? It's kind of mindless. So the and also is going to short circuit the evaluation process and say, hey, if I can't possibly win, don't continue playing, right? The or similarly is going to say, if I've already won, don't continue evaluating. I've won, right? And so the both the or else and the and also are sort of short circuiting and cutting the logic that doesn't need to be tested when you've already determined either that the expression's result has to be false or cannot be true. Don't waste your time. Or we've already, in the case of the or, we've already met the minimum criteria. We don't have to evaluate any further criteria. We've won. Stop. Just go ahead, declare victory, and move on. And so these are going to be more efficient operators. There's also some esoteric cases where you might have something that if one condition happens to be true, the other one cannot be a valid expression. You would have to otherwise do some error trapping and say, wait, 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 we've done this, so don't bother to evaluate that. It'd be a much more complex expression. Because of this short circuiting, if this happens to be an illegal expression when this is true, then you wouldn't have to worry about error trapping that when you use or else, because or else is going to not bother to try and evaluate it. Whereas when this is false and there's a possibility that this could be true, but it would therefore have to be a valid expression, um, then it can be a little bit more efficient. That's a pretty esoteric situation. You don't often run into it. I'll mention it just in passing for the sake of completeness. But there you are. So using KeyPress Event to do data validation, and also why or else and also might be might be about it, are more efficient in general than or and understanding the subtleties of the difference, and situations wherein you might want to force both sides to continue to be evaluated even when um, you've already either determined the expression can't be true, or in the case of the or, where the expression has already satisfied the requirement. Boy, I'm having a hard time thinking when you would want to do that, but that's the distinction between the two there. And I think we'll leave that at this point. You should go ahead and play with the key press and think about ways to challenge yourself. What if you wanted to also allow a range of alphabetic characters? What about only uppercase or lowercase? We've seen another way to do that, or a subset of those. Or if you want to have only alphabetical characters, let's say we've got a part number that is 5 digits long. The first 2 characters are always alpha, and the next 3 are always numeric. Could you make a validation routine for that? So play with it, have some fun, challenge yourself with it. I think you'll find it's really kind of an interesting event handler. This concludes the lesson.